The modern world is unimaginable without space flights, satellites, nuclear energy, fundamental physics, chemistry, and other fields of science, which appeared exclusively or in part thanks to Russian and Soviet scientists. Laser technologies are among such achievements as well. Thanks to the work of Nikolai Gennadievich Basov, Joris Alferov, and other outstanding compatriots of ours, the world received the laser and the opportunity to use it in a wide variety of fields, from medicine to thermonuclear fusion, and of course, the increasingly popular 3D printing. With the help of lasers, special 3D printers are used to create parts that are often impossible, too expensive, or too time-consuming to produce by other means. In Russia, the technology is rapidly making its way into the space, aviation, and other industries, but as always, just in time. The main question becomes about the means of production. Can we make our own 3D printers? 25 years ago, a group of graduates from the Baltic State Technical University, VOINME, founded a research and production company specializing in laser technologies. Today, it has grown into Laser Systems, a world-class manufacturer of 3D printers for metal printing. We'll show you their products, but first, let's figure out how items are actually made from powder.
Basically, the mechanics are quite simple. There's a metal plate where the growth takes place. It's on a movable table that can go up and down, and the lowering step is small, usually 30, 50 or 80 micrometers. The table lowers, a layer of powder is spread, and the powder is welded to the metal plate with a laser beam. Then the table lowers again for the next build step, a new layer of powder is spread, and the synthesis is repeated, but this time following the path of the next layer. It's similar to 3D printing with plastic, but the layer is thinner, and here we're using metal powder instead of plastic. As a result, you get a well filled with powder, in which the manufactured part is fused from metal powder and is surrounded by the powder. Then the platform rises, the powder is removed, and the part along with the build plate is sent for heat treatment. After normalizing annealing, it is cut off from the build plate. Basically, that's how the SLM process works.
And then the part requires machining?
As a rule, machining is required afterwards. In any case, additive manufacturing is still a blank production process, and in fact you get a blank, but this blank has a high degree of readiness in machining. There is either a minimum required or none at all. If the part is properly designed, often there is no post-processing needed at all.
Is the excess powder remaining after this procedure reused or not?
Yes, as a rule, with rare exceptions, all the powder that remains after synthesis goes for resieving is refreshed with new powder, and then it can be used again in the same way. The mechanical properties remain nearly unchanged, and the powder usually has a long service life. That is why additive technologies, particularly SLM, have a very high material utilization rate. Here it reaches 95% and sometimes 98%. And that's why additive technologies can demonstrate a good economic effect, at least due to the savings alone. Attention!
Where do you purchase the powder? Is it foreign or already Russian-made?
We can work with foreign powder, but as a rule, we use Russian-made powder. There are about 10 to 15 companies in Russia that produce high-quality powders at a world-class level, and we use their products.
Laser Systems work with powders of stainless steel, titanium, heat-resistant nickel alloys, cobalt chrome alloys, bronze, pure copper, as well as with specific materials such as titanium nickelide or soft magnetic permalloy. One of the main consumers of the products we produce is the space industry.
As a rule, additive technologies are most applicable and provide the best economic effect for parts with the most complex shapes and geometries. Here, for example, is a bracket for a satellite antenna that we made together with an enterprise from the Roscosmos group. This bracket was originally made using classical methods by machining on a CNC machine and had a certain material utilization rate, well, probably around 10 or 15%. After topological optimization, after modifying the design, with all other conditions being equal, with the required strength and rigidity of the structure, it was possible to make it lighter. By almost 100 grams, which means it's about 30% lighter. At the same time, the material utilization rate here reaches about 90 to 95%. Well, and 100 grams of weight savings for space is a very significant figure because every kilogram of payload in orbit on our planet is very expensive. A similar product, also for space, for the same customer, is this kind of antenna for a satellite. What's amazing here is that basically, after redesigning this structure for the additive manufacturing process, these products are grown, annealed in a furnace, cut off, and subjected to sandblasting. Overall, all of this is done within a single day, and the antenna is immediately ready for use in this form. In terms of its radiophysical properties, it is not inferior to the original sample, but it is manufactured much more easily, faster, and with much less labor. We print quite a lot of such products. This is a microwave antenna, probably from some radar. It's both a horn antenna and a waveguide structure, all combined in a single part. Originally, this was probably an assembly, but additive technologies allow us to grow such products as a single piece.
To ensure the quality of the printers and products, a special laboratory operates at the facility. The sample is placed in a tensile testing machine, which stretches and breaks it. All the parameters of this process are measured and analyzed, and then conclusions are drawn about the presence or absence of defects.
Now we'll see the sample break in literally a few seconds, judging by, oh, it broke. Our laboratory also has equipment for studying and conducting metallographic analyses. Here is a sample like this. This is already a prepared specimen. We grow cubes, cut them, grind and polish them, and then examine their internal structure under a microscope. Residual porosity, that is for most materials, no more than 0.1% is allowed according to our internal regulations. This is quite a high synthesis quality, so the products turn out to be solid, withstand pressure, and such residual porosity is roughly equivalent to the level of pressure casting or even somewhat higher.
The company Laser Systems produces a line of industrial 3D printers of its own design at its own facilities, with the flagship model being the M450L, which has a build area of 500 by 500 by 500 millimeters and 4 laser channels.
We are entering the assembly room for our 3D printers. Here, usually from 3 to 8 printers are assembled at the same time, depending on, let's say, the season or the time of year. Right now, we have 4 or 5 of our senior models here. In the mid-range segment, these are the 350 series machines. Through these gates, the 3D printers are then shipped all over the country. Now, there are already several dozen of them installed across the country. Overall, for our country and considering the relatively small market, the complexity and cost of the technology, these are very good results. This is our flagship model, a large, powerful industrial unit with a build area of 500 by 500 millimeters, and the build chamber depth is also 500 millimeters. This is in fact, yes, at the moment our flagship is already an industrial machine, large and serious. Here, if you calculate the total volume of stainless steel, the mass of the powder will be over a ton. It's already a 4-laser system, 4 channels can work here, and on such a large build area, single laser or dual laser solutions are no longer sufficient. They don't work because they don't provide the required performance and synthesis efficiency, but 4 channels or more are already applicable in this size. We have plans to develop this product line for larger sizes, up to a meter, maybe even more. There will be 8 to 16 channel systems, and of course we plan to develop all of that in the future.
Can you give some examples of products that are in demand in these sizes?
Again, there are many examples in this size. There will be high demand for products for the oil industry. These include impellers, the appropriate tooling, and products for drilling rigs. There is a high demand for this size there. In general, a large size is not just one big specific part. Here you can also produce many small parts, just with higher productivity.
Whenever we talk about manufacturing high-tech equipment like yours in Russia, the question of the origin of the components always comes up. How much can your products be considered Russian?
Obviously, we don't make all the components here at our facility, but we have a fairly high percentage of components that are Russian-made. Moreover, the machine itself is entirely our own design, and we do a lot of the work ourselves here. These are the metal structures, frame elements, optical elements of the controller, software, and the metal structures on the chassis.
The laser source is of Russian manufacture?
The laser source, of course, is of Russian manufacture. It's VPG Laser One Company, Moscow, Fryazino. Well, I think everyone in the field knows them.
Actually, science is everywhere in laser systems, not just in 3D printers. Its developers, among whom there are more than 40 PhDs and doctors of science, were able to create other original products using laser technologies, for example, this one.
Alexei, what is this friendly robot that looks like some character from a famous Hollywood movie like Star Wars or something like that?
This is a meteorological device called a wind LiDAR. A scanning cone is built upwards along the beam, and at altitudes up to 300 meters it determines not only the backscatter profile, that is, cloudiness, the upper and lower boundaries of clouds, and the density of atmospheric formations, but also the speed and direction of the wind, up to 300 meters. Accordingly, such devices can be placed near landing glide paths to detect dangerous meteorological phenomena such as wind shear, gusts, turbulence, and so on. It's quite a good and interesting device for ensuring flight safety. Only a few companies in the world produce such devices in series based on the same physical principles. Well, for example, Lockheed Martin can do this, Mitsubishi can do this. There is a European company called Leosphere and the Finnish Vaisala who can make such devices. Well, that's basically about it. And of course, the laser system, we also have this technology in Russia. It's quite complex equipment with complicated mathematics and physics. Basically, the heart of such a source, such a LiDAR, is a laser source with a coherence length of more than 60 kilometers.
And here is another original development by the company Alkoramka. Such a device is installed at the entrances of large industrial enterprises and prevents people in a state of alcohol intoxication from being allowed to work. It is impossible to deceive or disable such a controller.
Essentially, it is an optical spectrometer that is tuned to the alcohol molecule and water absorption. It works very simply. You just need to exhale in a contactless way, and within 2 to 3 seconds we get the result. A short exhale and we immediately see the results. You can try it if you're interested. Now I'll show you the exhale of a drunk person. I don't drink, so I won't consume it. I'll just inhale alcohol vapor. And look, we immediately see a reaction of 1.4 per mille. And if, at an enterprise, when passing through the checkpoint, a person produces such a reading, they must undergo additional medical examination and should not be allowed into the enterprise.
The question arises naturally. Is it possible to trick it, for example, by blowing somewhere to the side, or on the contrary, by inhaling instead of exhaling?
Yes, that's a good question. Everyone asks it, but in reality it's almost impossible to trick it for the simple reason that it detects the very fact of exhalation. Exhaled air differs from the ambient air because of its humidity. Exhaled air has more humidity. If we inhale and exhale to the side, it won't detect the exhalation and will ask you to repeat it. For example, I can exhale to the side right now. No reaction will occur. Exhale directly into the chamber. Please.
Traveling to different factories across Russia, we constantly encounter the problem of a shortage of qualified personnel. How do they handle this issue in laser systems?
Ourselves? Historically, 25 years ago, we emerged
all from Vonme, that's BSTU Vonme. And the original training ground for specialists was from there. Of course, later other universities joined in, Polytech, the big university, Leti and ITMO. Until recently, I was an associate professor at the Vonme department. Starting in the 4th year, it's a great training ground for specialists. When we see young specialists, people we've already observed a bit during the educational process, without distracting them too much from their studies, we start inviting them for internships at enterprises for some hands-on industrial practice and so on. Starting from the end of the 3rd or the 4th year, we bring in specialists as interns to work with us. This is a big job and it requires an innovative approach from the specialists who are already working with us. It's their time, but in the long run, it provides us with personnel. There's another point. Yes, we have a lot of work related to things that are interesting to young people. Even though everything in this world is changing, for example, the space field is still interesting to young people, and we have a lot of it. We have enough projects with Roscosmos, and we attract people to work in the space industry. It's interesting for a young man or woman. The excitement about space is still there, and the fact that we are engaged in high-tech, what is called high-tech. Yes, in the field of machine tool production, this is also interesting because it's a complex thing. It combines electronics, programming, and traditional engineering activities. This is also interesting for young people.
We know that our people are capable of making discoveries and creating brilliant products, but in today's world, that's not enough. You also need to be able to set up mass production, build a sustainable business, and compete in both domestic and international markets. We discuss this and the future direction of additive technologies with the chairman of the board of directors of Laser Systems.
You come from a scientific background. You worked on research related to laser technology. Why did you choose additive manufacturing as your main direction?
After all, everything here is basically a perfect fit. There are specialists in gas dynamics, specialists in laser technology, and SLM technology, selective laser melting, is really at the cutting edge. It's the very quintessence of it all. Basically, all those things we've been working on are embodied here. It's the same situation with additive technologies and industrial safety systems that we're working on. The foundation we developed when we were a purely research-based company, a small enterprise, is now allowing us to achieve good results in certain areas.
The market you work in, additive technologies, especially in industry, is still in a rather early stage in Russia.
Everywhere has its pros and cons, and the emerging market is basically understandable. Here, it's clear that if you make a product that's better than your competitors, basically cheaper, or on the contrary, maybe more expensive but significantly better, that's the way to go. That's basic marketing economics. So basically, you can move forward. But in this fast-growing market, it's very important, of course, to make a product that will resonate. And for us, you see right now, again, all these external conditions basically contribute to the development of this technology. Because for production continuity, for solving import substitution tasks, additive technology is actually one of the key technologies. So, well, right now everything is favorable for this, but in general, it's a global trend. And we are also closely monitoring everything. This actually speaks to the increasing implementation of additive technology, not only thanks to topological optimization, yes, and not only because there is some economic effect in small-scale production. As practice and calculations show, the practice that has already been implemented in, for example, China, and we know now that similar practices of creating large additive technology centers are also being adopted in the West, just like in China. There, the law of large numbers is already at work, yes, and thanks to so-called dark manufacturing, that is, production without involving operators, a positive economic effect is achieved, not only in some complex parts or parts that require topological optimization, but also in mass-produced products. Even compared to traditional methods, the introduction of additive technologies is taking place. This is because, in principle, costs are reduced, powders are becoming cheaper, and equipment is also becoming more accessible. Yes, further on, at certain volumes, a good economic effect starts to appear in the long run. This technology is very good, really good, and here again the question arises, how do we manage to take advantage of all this? Well, lower quality. Well, quality is actually the most important thing. That is, yes. That is, if the client understands that the delivered product, the delivered machine, produces an important good product of the required quality. In addition to this, even if something goes wrong or some questions arise, our specialists respond to you immediately. They come out right away and solve problems on the spot. Well, thanks to this, probably thanks to this, we are now showing such significant growth in this area.
You have two business areas, selling ready-made machines and additive manufacturing services, which you provide at the request of clients. Which of these areas do you think is more promising?
Well, if you look at marketing research, including Western ones that reach us, the situation is described as follows. The prevailing share of revenue in these areas is, of course, generated through providing services. In our country, this is not the case yet, but probably if we talk about the future, then providing services, that is, creating these additive technology centers, will eventually generate more revenue than selling these machines directly to the end user. But for now, the situation is the opposite. We earn more from selling machines than from printing services. Well, we understand this, and this year we've started this activity, and next year we will continue it. We are scaling up these centers for additive technologies. Right now, we have one here and another one is opening in the Republic of Tatarstan. We are already having intensive negotiations with several regions about creating such additive technology centers in those regions based on our equipment and with all our technological support. And I think in principle, this will help to balance things out a bit.
It's like a regional franchise.
Well, we have different schemes that we use now. But overall, it really looks like this. Together with a partner, we invest jointly in opening this center, and then it operates as a separate business unit. This center works to meet the needs of the region and nearby areas. We are expanding our technology in this way.
Sooner or later, we will have these lights-out factories for providing additive services in the regions.
Yes, that would actually be wonderful. Well, I think in principle we will actually get to that point.
There will be a way.
Maybe it won't be very simple either, but we will get there.
Yes, we have seen your wonderful production complex. Everything is great, but we can see that in some places it seems a bit cramped in some of the workshops. What are your plans here?
Everything is clear here. Yes, you are right. We basically moved into the special economic zone about 10 years ago, maybe even more. We built the administrative and production complex, and now we are here. Well, we are developing, which is a normal process. Our orders are increasing. Yes, our order portfolio is growing, so we need new facilities. And right now, we are at a specific stage of expansion. That is here on the territory of the Special Economic Zone. We are planning to build another production complex in the next couple of years.
Is there any support from the government?
How significant is it? You know, I can say yes, there is support, but we have earned this support to a large extent. What do I mean by that? We produce products that fully meet the criteria for being recognized as Russian. And thanks to this, our products, so to speak, are included in the so-called GSP, which is an international system for international trade in products. And if they are included there, then accordingly, we have the right to use various benefits when supplying equipment, for example, within Russia, in order to stimulate sales and purchases of domestic products. The state subsidizes this. Yes, there is a subsidized discount for the end user. This is really the most interesting mechanism among those we use. There are various other aspects of state subsidies and development programs. Does it help you? But in return, they require us to comply with certain covenants, for example, that for every ruble invested in us, we must show 2 or more rubles of revenue in this area. Well, again, you see the situation now is that our problem is forming inventory because everything is sold out, but the period is quite long. That's why these covenants are a difficult issue for many industrial enterprises. For us, in principle, fulfilling them is not particularly difficult because the product we make is really in demand. So yes, the government does provide certain support. But again, what we like to use the most right now is, of course, this end user discount. It's good for the end users, and it's nice for us too. In general, it makes the industrial machine buy Russian products. It makes everything work, and that's great.
And probably the last question, a little bit about the future of the business. It's more or less clear where you have room to grow. You have the huge untapped Russian industrial market, and then you'll go beyond it. That's all inevitable. But technologically, where do you see growth for yourself and for the industry as a whole? Because, you know, from an outsider's perspective, it's like, here's one printer, then another with a slightly larger working area, and it seems like everything has some kind of physical limit. Everything has its limits.
You see, the printer is so big, there's a black box, right? And inside, there's so much going on, a lot of interesting things. And of course, there's this meticulous scientific and technical work going on to optimize the internal processes, you know, the things inside to make everything work faster and get better results. So actually, the optimization of technology is happening continuously. In addition to that, of course, we have a special department for advanced technologies where we work on things in parallel. Some things are, well, not exactly spin-offs, but something more like that. Major upgrades of this equipment, so to speak, where we're not just looking one step ahead, but several steps ahead. Thank God there's competition, because competition doesn't let you fall asleep or rest on your laurels. It makes you move forward. That's why we fully welcome competition. It's great.
Do we have a chance in this global competition, as you just said, to look a step or two ahead and create something of our own, something Russian, fundamentally new, fundamentally better, specifically in this direction?
We definitely have a chance. I would even say, knowing all the ins and outs of this field, including the scientific aspects, I consider our chances to be quite high.
Excellent. Well then, we wish you success in making the most of these opportunities and in developing your business.
Thank you very much. Thank you.
If someone tells you that there are no high-tech companies in Russia with top-notch, science-driven products, just show them this video. Show it also to those who are sure that it's impossible to grow a successful company from a student startup in Russia. We are convinced that Laser Systems will surprise us more than once with their developments. And outstanding Soviet academicians, the creators of the laser, would definitely be pleased with what they see. Subscribe to the Time Forward channel to stay informed about the development of Russian industry.